Pythagorean theorem and calculation of angle. Pythagorean's theorem is a mathematical formula that relates one side of a right triangle to the other two sides. Let's take a look at an example of Pythagorean's theorem, which is a mathematical formula. Namely, the equation a squared plus b squared is equal to c squared. Here we show an example of a right triangle that has the smallest side labeled small a, which I have equated to 2 meters. The medium size of the right triangle has a length small b, which is equal to 3 meters. And the hypotenuse, or the longest length, is labeled small c, which is equal to 3.6 meters. We know the lengths of all 3 sides of the right triangle. However, we don't know the angles interior to the triangle except for the right side of the right triangle, which is 90 degrees. We would like to solve for angles A and B, knowing the lengths of small a, small b, and small c. So let's do a calculation to solve for angle. We have an example where we can use tangent angle is equal to opposite over adjacent. You can use sine of the angle and cosine of the angle. We choose to use the equation for tangent of the angle. Now let's choose which angle we want to solve for. We can choose for capital A or capital B. Let's choose for capital B, for which the small b length is opposite to angle capital B. The tangent for capital B angle is the length of the opposite side divided by the length of the adjacent side. Find the angle capital B and then look for the length opposite to the angle, which is small b, and has a length of 3 meters. In the denominator, you want to put the length of the adjacent side. So find the angle B and never choose the hypotenuse. Choose the length that's the adjacent side, which is small a, or 2 meters. Now we can simplify because we have meters in the top and meters in the denominator, and they cancel out. And we're left with an equation of tangent B is equal to 3 divided by 2. Now we want to solve for angle capital B. The equation to solve for angle is equal to the tangent inverse of opposite over adjacent. So you're looking for tan to the -1, or tangent inverse, open parentheses, the opposite length divided by the adjacent length, close parentheses. So let's substitute in. Since the tangent of the angle is B, our angle would be B. So B is equal to the tangent inverse, and we're looking for the opposite length, which we've already called 3 meters. We got rid of the meters, so we could just put 3 there. And the adjacent length is 2 meters. Since we got meters and they divided out, we can just put 2. So we have the equation B is equal to the tangent inverse of 3 divided by 2. So how do we solve for this? Well, let's go to our Google calculator. Here's our Google calculator, and we have to decide if we want to solve in radians or degrees. Our degrees is highlighted, so let's solve for it. So now we want to look for not tan, but we want to look for the inverse, and there's our tan inverse key. So we click on tan inverse. And we see arctan up here, open parentheses, close parentheses. So now we need to fill it into our parentheses, which is 3 divided by 2. So we click on 3, hit divided by 2, and notice that the 3 divided by 2 is inside the arctan. We hit equal, and our angle is 56.3 degrees. So our solution is that angle B is equal to 56.3 degrees. Now we're not done here because we have to give a direction. Usually we have to give a direction. So I went ahead and gave an axis. The vertical axis I labeled north, and I made an arrow going to the right as labeling east. So our angle is 56.3 degrees. And notice I drew my arrow from the east going upwards in the northerly direction. So I would say 56.3 degrees, that is north of east. So you start at east, and then you go northward in the northward direction, 56.3 degrees. You can't say northeast because northeast is exactly 45 degrees. Since we don't have 45 degrees, we can't say northeast. We have to say north of east. So that's my angle. B is 56.3 degrees north of east.